Okay, class, what we have here is our next lessons in quadratics. This one we're going to focus on graphing. So solely our objective is down here in the corner here is really pretty much just to be able to accurately graph a quadratic function. So we want to know starting point, vertex, the curvature, other accurate points, and so forth. Okay. First thing we have to know is that we're looking at the function ax squared plus bx plus c. Once we see the x squared, we know it's quadratic. Every quadratic is the same shape. It's a parabola. And what it looks like is this. The parent function of simply this f of x is equal to x squared. This is simply x squared, the most basic quadratic of all. They all look like this. Starting point in 0, 0. And it has a parabola shape. And we know, I'll just draw it off to the side, it's almost this U/V shape. Okay, and it has a name. It's called parabola. And how do you find it? It has this stepping motion. The left and right are both symmetrical, so we have an axis of symmetry right down the middle. So I'll just dash that in here with the dashed line. And for every one spot you go over 1 and up 1. So notice I want over 1, up 1. Next time you go over 1 and then up 3, and then over 1 and then up 5. So you're going up by odds. And I'm going to do the same on the left-hand side. I go to the left 1 and up 1, to the left 1, up 3, to the left 1, up 5. So you have the stepping notion. 1, 3, 5, dot, dot, dot. Okay? And if I sketch this curve in, it's going to look something like this. So it's going to follow this curvature, and we call this a parabola. Now notice, again, for every one I go over, I go up 1, and then I go up 3, and then I want up 5. So it's like almost climbing a staircase where the stairs get steeper and steeper as you go up. And again, that's for going every one over. So that is what we use for that. Okay, now looking at these other elements up here, direction. For direction, you're looking at the a value. If the a value is positive, then the curvature of the parabola is going up. If the a value is negative, then the curvature is going down. The vertex is simply this. Opposite of b over 2a. That's your x value. And then the y value is you take the x value, put it into the function, you find the function of that. So you evaluate it. So it's the function of negative b over 2a. And we'll see examples of that. So that is the point of the vertex. Axis of symmetry is simply x equals, it's a line, like the dashed red line here, negative b over 2a. And again, that is the middle of the parabola. We call that the vertex. Y-intercept, in this case, is always going to be 0, c. That's when you plug 0 in for x, and notice the only thing left would be the c value right here. And then for symmetrical point, this is based on the axis of symmetry, so we're going to use the y-intercept to find that. And additional points, this has to do with the stepping motion. Okay, so we'll look at that in the example. So I just want to fill that in so we kind of have a good look and see what we're looking at. All right, so let's look at a couple examples to show how this all ties in. We want to know how the parent graph is transformed or translated on the graph, and then these other key elements, the vertex, direction, and the like. So let's take a look at the first example. First thing we want to do is recognize what we have. The a value here is obviously negative 1. The b value, we don't have a b. So it's 0. It's like 0x. And our c value is 7. Okay. Now looking at this value, this equation, notice I see the x squared. So that is my parent shape. But notice the negative. The negative tells me the direction is going downward. Okay. So it's going to look down like that. And I had this positive 7, which means my starting point is now at 0, 7, not 0, 0. So instead of starting at 0, 0, I'm going to go up to 0, 7. 1, 2, 3, 4, 5, 6, 7. So that's my new starting point. And since it goes down, my curve is going to go down. So this time, instead of going over to the right and up 1, I'm going to go over to the right and down 1. Over to the right, down 3. Over to the right, down 5, and so forth. My axis of symmetry still goes in the middle. And then the left-hand side is symmetrical. So notice this point here is over 1, down 1. Over 1, down 3, over 1, down 5. And notice my symmetrical point and my axis of symmetry is the same. Okay? So there is a sketch of my curve. And notice I used the steps for this one. Okay? if I do define the vertex here, this is what I'm finding right here, that is again going to be negative b over 2a. Well, let's just plug our value as in. We have negative 0 over 2 times negative 1. Well, that obviously is 0. So 0 is the front half of that point. Plug 0 into the equation, so I'm going to have negative 0 squared plus 7. Well, that's going to equal 0 plus 7, which is just simply 7. So our vertex, our starting point is 0, 7. We found that by the translation here. Okay. What's the axis of symmetry? Well, it's simply the vertical line here in green, which is x equals the front value of the vertex, which is 0. Y-intercept, it's the same thing, 0, 7. Symmetrical point, now notice we can't use the y-intercept. So here, I'm going to find me an additional point. So for the additional point, I'm looking, okay, let's just pick this point right here. So that point right there is 2, 3. And what's symmetrical to that? Well, let's see. Over here, we have negative 2, 3. Okay? So there is some information on that curve. Okay? Notice we're able to find all the key points, able to graph it accurately using the stepping, the starting point, the direction, and so forth. Okay? Let's look at another example. All right, so this one here, I'm actually going to go the other direction. I'm going to find all this information first. So I'm going to start with the direction. It's a positive 2, so the curve's going up. Okay? I have negative b over 2a. Notice I just used a skeleton equation, and then I'm going to plug in my a and b values. There's a, b, and c. So we have negative 8 in for b, 2 there. So we have positive 8 over 4, which is simply 2. So here I'm going to plug 2 in for my vertex. I'm going to plug it into the equation. So we have 2 times 2 squared minus 8 times 2 plus 3. Notice again, this evaluating. So again, this is function of 2 is equal to this. So we have simply 4, 8 minus 16 plus 3, which is going to be negative 5. So the function at 2 is equal to negative 5. So I'm going to plug that in as a point. So now, right away, I'm going to go to my graph and go over 2, down negative 5, and put a starting point. I am going up. Okay. Now notice, my y-intercept is simply 0, c. And here's my c value right here. So I'm going to plug that in, 0, 3. And I'll put that on the graph. Now notice I do my stepping motion. If I go over 1, up 1, over 1, up 3, over 1, up 5, I end up in a different position way over here. Okay? So we can't do it that way. So we have to then adjust our stepping motion. And how is that affected? By the a value. Notice we have an a value 2. That means this thing is stretched out twice as big. So instead of having the values 1, 3, 5 of a stepping, I'm going to multiply all those by the a value. So instead, I'm going to get 2 times 1 is 2. 3 times 2 is 6. 5 times 2 is 10. I have now stretched my stepping motion. So I'm going to go now over 1, up 2. Over 1, up 6. Notice I land at the y-intercept. Over 1, up 10. And it'll be somewhere way up here. Looking at my symmetrical curve, I draw my axis of symmetry, which is obviously x equals 2. I'm going to do the same on the other side. Over 1, up 2. Over 1, up 6. Over 1, up 10. Have a dot way up there. So now my curve is going to follow like this. So notice the same curve, but now it's stretched out. It is twice as tall, so it looks a little skinnier, and that's adjusted by the a value. So the same curve, so we basically had the parent graph shifted over 2, down 5 to a new starting point, a new vertex, and then stretched twice as tall. So now what do I have symmetrical point? Well, here's my y-intercept at 0, 3. My symmetrical point across the axis of symmetry is 4, 3. So I'm going to put that down for my symmetrical point. Additional point, you can pick any point on here. Why not? Let's pick this one right here. So that's over 3, down negative 3. So I'm just going to fill in any point on the curve. Again, just getting additional information. So notice in this one, we had a different a value, so our stepping changed. We had to find the vertex using negative b over 2a. And again, still get all the same information. All right, let's look at this one here. Again, I'm going to start with my starting point, so negative b over 2a. Here I have negative 6 for b, and a is simply 1, so we have 6 over 2, which is simply 3. So 3 is my starting value. I'm going to plug 3 into the function, and we get 3 squared minus 6 times 3, which is 9 minus 18, which is simply just negative 9. So it's going to look like that. So 3 comma negative 9. Once I have a starting point, I'm going to go ahead and put it on the graph. So it's going to be right down here. My graph goes up because of a positive a value. X is a symmetry. X equals 3. Y-intercept, notice we don't have one. I would put plus 0. So my y-intercept is 0, 0. We don't have a c value, so we plug it in. So that's going to be 0, 0. Okay, so from this information, if I draw my x as a symmetry at x equals 3, notice I can find my symmetrical point very quickly. And we know our curve is going to go through there. So let's follow the stepping motion, and let's see if we have it figured out. My a value is 1, so I'm going to go over 1, up 1, over 1, up 3, over 1, up 5, over 1, up 7, and so forth. Okay? So now we have a curve that looks something like this. So the rest of the dots on the left-hand side, and you just connect the dots. So this is a very good way to get an accurate drawing here. So symmetrical point, I'm going to put in the point 6, 0. And for additional point, I can pick any point. Why not this one right here? So we have 1, negative 5. Okay. So notice how we very easily get the proper points and graph from that information. Okay, again, I'm just going to kind of quickly go through this one here. I believe this is our last example here. Okay, so things I'm noticing, negative 2 for my a value, so it's going down. I'm going to go ahead and find my vertex. So I'm going to plug in my values of negative 8, negative 2. So we have a starting point at negative 2, comma, and again, I'm going to plug in negative 2. Okay, and for this one here, we're going to get simply this negative 4 after you go through all the math there. So we have negative 2, comma, negative 4. So we go back 2, down 4, and we have a starting point right there. Since it's going down, I'm going to use my stepping motion right now. And I know we're going down by a factor of negative 2. So I'm going to go over 1 and then down 2. Over 1 and down 2. So I'm going to do the symmetry right away. Let's go ahead and draw in our axis of symmetry through the vertex. Okay, and then we're going to go over 1, and it's not down 3, but down 6, because I'm multiplying by 2. So over 1, down 6. So I'm going to go a little bit off the graph here on both sides. And again, we have a curve that looks something like this. Where is my y-intercept? At 0, negative 12. And let's look at the graph and see if it lines up. Looks to be right here is 0, negative 12. And a symmetrical point, well, we can simply say it's going to be negative 4, negative 12. I'm just looking on the other side of the axis of symmetry. Axis of symmetry, again, is x equals negative 2. And additional points, again, we could pick any point, so I'm going to pick that one right there. We have negative 1, negative 6. Okay, so again, I'm just picking different points off the graph. Find the vertex, direction, axis of symmetry, use a stepping pattern to graph the function. All right, so here we have a couple problems I want you to try. I'd like you to try problem number 1 and 4, which are highlighted. Off to the left, if you want to print this out and fill them in there, you could obviously just put both graphs on the same graph paper so you can kind of see the difference between the two. But let's go ahead and try that for our next lesson, okay? And then later on, we'll talk a little bit more in depth on applications of using the graph and how it ties into solving as well, okay?